So counting atoms. So we can draw and we can write, but what does it tell us? So we can learn more about the chemical compounds by looking at the subscript that follows the chemical symbol. Now in the case of methane, which is CH4, there is not a number after carbon. However, there is an understood 1, so that will imply there's 1 carbon to 4 hydrogens. You can also just see that there are, for methane, let's get the laser pointer out. So for methane, 1 to 4. Many compounds indicate the atoms by subscripts. So any non-1 value has a subscript. Sum of quantities in parentheses is a repeated number of these molecules. So we'll start learning about polyatomic ions. Poly means many, atomic, atoms, so there's many atoms. So in this case, we know that there is 1 magnesium because there's not a subscript here. However, inside the parentheses, you see there is an oxygen and a hydrogen. With the parentheses, you see that there's a subscript 2. This 2, just like you would do in math, would be multiplied for both elements. So there's 2 oxygens and 2 hydrogens. Here, there is, again, 1 magnesium. But you have, inside the parentheses, carbon, hydrogen, oxygens. And each of these values get multiplied by 2. So you don't have just 18 carbons, you have 36. And 50 hydrogens total. And 4 oxygens. Sometimes you'll see a hydrate. Hydrate indicates that there is a water associated with this compound. And you'll learn more about this in a few labs from now in 1110. In that case, you'll see something different where you have a molecular formula with a black dot, and that indicates that there are full water molecules for your compound. So in this case, you have calcium, and this sulfur oxygen compound is a polyatomic ion called sulfate. So this is calcium sulfate, and there are 2 hydrogens. There are 2 water molecules associated with this calcium sulfate compound. More about hydrates can be found in section 2.3. And please read over this section and be prepared to answer questions on the quizzes or homework about it. So what we'll go through, this is not a clicker question, we'll go through counting the atoms. So you can pause the video if you want and write down what you think, and then we'll go through the answers. So, how many sodiums? How many carbons and how many oxygens? This subscript indicates there are 2 sodiums. There is not a subscript for carbon, so it is 1. And then there is a subscript under oxygen. Notice there's no parentheses, so this 3 belongs just to the oxygen. Here, we do have a parentheses, so whatever is outside the parentheses get multiplied with everything inside. So there's 2 nitrogens, not 4 hydrogens, but 8, 1 sulfur, and 4 oxygens outside. And you can continue on with the other examples with the polyatomic ions. Notice, again, there's a difference between the subscripts and what we call a coefficient, and the coefficient's in front. If there's not a value here, you can assume 1. However, this value, this water value, has a coefficient, and it's just in front of water, so that means this gets multiplied by everything following it. So this 5 does not affect this copper or the sulfur or this oxygen, but it does affect this oxygen. So you have 1 copper, 1 sulfur, 4 oxygens from this compound, plus 5 from water. And then you have 5 times 2 hydrogens. And more practice with the parentheses. So now we know how to draw and how to write chemical compounds. But what does this tell us about what we've learned before, about what we know about atoms? So remember, we went through Dalton's atomic theory. And from Dalton's theory, we learned and we went over 2 laws. We talked about the law of conservation of mass and the law of definite proportions. So the law of conservation of mass says we cannot create nor destroy mass. Whatever we have has to be accounted for. And the law of the definite proportion states that whatever elements or whatever ratio by mass those elements are in order to maintain the same compound, the ratio does not change. So another way of saying it, for a given compound, it always has the same amount of atoms by weight in the same ratios. What this leads, though, is that what we call the law of multiple proportions. And that means some elements combine to give 2 or more compounds, which means the ratios do slightly change. What's important to take into account is that we deal with whole numbers of atoms, not fractions. And so there's some examples on your homework. And if you struggled with this in Chapter 0 or Chapter 1, you might struggle with the math in Chapter 2. But the theory is still the same, that the ratios are the same, but not... the ratios are the same for each compound, but just because you have a sulfur and an oxygen doesn't mean it's always going to combine in the same compound. So sometimes you'll see sulfur with 2 oxygens, and sometimes you'll see with 3, and so forth. And that's important because that affects how these molecules and how these compounds are going to interact. In order to distinguish between these molecules and compounds, they have different chemical formulas, but they also have different names. So we talked about drawing and we talked about writing, and this leads us to naming compounds, because if each element behaves the same each time, we have a simple naming system. However, this law of multiple proportions makes our life a little bit more difficult. So the nomenclature in naming compounds is in this class we follow the IUPAC system for the standardized naming of our chemical compounds. So remember, we're going to cover 2 types of compounds, molecular and ionic. So molecular compounds are a little bit more difficult to name. Now these molecules are electrically neutral, meaning they do not have a charge. these molecules consist of 2 or more atoms. And again, we talked about chemical bonds, and these are the interactions between 2 atoms. And in this case, the molecular compounds have what we call covalent bonding. And that is, in covalent bonding, is 2 atoms sharing electrons. Each group of atom makes up a molecule. So the group of atoms that make up a molecule behave as a single unit. So that means for H2O. H2O, we have 2 hydrogens, 1 oxygen. But together, forming water, that water molecule will behave as a singular unit. We use molecular formulas to draw, and it specifies number of each type of atoms present. So you do not reduce down these forms. For naming, we have our own particular prefixes that, yes, you will have to memorize. Please note that we use di, tris, and tetras. And this is particular for our molecular compounds. For the most part, we're going to ask you to name binary molecular compounds. If you see more than 2 atoms in a compound, go ahead and assume that there's a polyatomic ion somewhere. So binary molecular compounds consist of 2 different elements. To name the element, we start with the left going to the right. So in this case, the first element on the left is carbon. And if there is a singular element, so in this case there's understood 1 carbon, the first element only gets its proper name, just like you would read from the periodic table. So this would be carbon. The second element, you will change its name to "ide" at the end, so it would be an oxide. And then for molecular compounds, you also have to take into account the how many oxygens or how many elements you have. So in this case, it would be carbon. There's 2 hydrogens. You know from the Greek prefixes that means you start with di, so it would be carbon dioxide. In this case, again, you start with 1 carbon, but you see that there's 4. And you already know that Cl stands for chlorine, so you change the ending to "ide", and you have carbon, chloride. You have 4 of them, so you know it needs to start with tetra. So carbon tetrachloride. So, hydrogen chloride. Notice that it did not say anything about being in a solution. So this hydrogen chloride is not hydrochloric acid, 2 different things. So hydrogen starts with, so you know the chemical symbol for hydrogen is H, and you know the chemical formula for chlorine is Cl. Now that is a 2-letter chemical symbol, so you capitalize the carbon, you capitalize the C, and you have a lowercase l. There isn't a Greek prefix, so you can assume 1. So that would be hydrogen chloride, represented by this chemical symbol. We go a little bit more complicated. Phosphorus pentachloride. So phosphorus is represented by just a P. And then you have chloride. Now remember that penta indicates there are 5 chlorides. So you have 1 phosphorus for every 5 chlorines. And so the chemical symbol will be this. Please take a few moments to review